Hello everyone. So today our topic is arithmetic progression that we will be covering in this video, right? So let's learn what is the learning outcome of this chapter. So learning outcome of this chapter is first is understanding arithmetic progression, that we will be understanding that what is arithmetic progression first. Second, identifying the first term and the common difference. First we will be coming to know that what is arithmetic progression. Second, we will identify that what is first term and its common difference. First term and common difference. Basically, first term is represented by A and common difference is represented by D. I will explain you this later on. Now, next we will our learning outcome will be find nth term. How? By using the formula we can find nth term. And fourth, solving the real life problem using the AP. That means how can we use AP and in our daily life. Okay, now we will come to know that what is arithmetic progression. So with the help of two example, I'll make you understand that what is arithmetic progression. Let's say two example I'm taking. First, that here I'm writing 2, next 4, next 6, 8 and 10. If I ask you that what will be the upcoming term or next term in this series, so what is the common pattern that you are observing in this? So if you will see that, then you are observing that if we are adding 2 in the first term, so we are getting what? 4. If we are adding 2 in 4, then we are getting 6. Similarly, if we are adding 2, then we are getting 8. And similarly, if we are adding 2, then we are getting 10. So what will be the next term accordingly? So if we will add 2 in this, so we will be getting what? 12. Similarly, if we will add 2 in it, so we will be getting what? 14, and so on. We can find the upcoming terms of this series. I'll take you one I'll take one more example. With the help of that, I'll make you understand. Let's see. So here another example, let's say 5, 10, 15, 20 and 25. So what is the common thing here over? So here also, if you will observe that if we are adding 5 in 5, then we are getting 10. If we are adding 5 in 10, then we are getting 15. If we are adding 5 again in 15, so here we are getting 20. In a similar way, if we are adding 5 in 20, we are getting 25. So what will be the upcoming term or the next term? So same, we have to add 5 in 25, so we will be getting what? 30. And similarly, if we will add 5 in 30, then we will be getting what? 35. And so on, we can find the upcoming terms, right? So where the common difference between two consecutive term, and what is two consecutive term? Let's say this is 2 and this is 4. So these two will be called as consecutive term. And what is the difference between these two? That is 2. What is the next consecutive term? If you will say, if you will take 4, so what will be the next consecutive term? Next consecutive term will be 6. For 4 it is 2 also and 6, so I'm taking right now 6. So here 4 and 6, so what is the difference between 4 and 6? It is 2. Similarly, if I will take 15, so what is the consecutive term for 15? It can be 10 also, it can be 20 also. So let's check whether the difference is same or not. So 10 and 15, the difference is what? 5. And 15 and 20, the difference is also 5. So in any two consecutive term, you will be finding that the difference is what? Same. So in this case, these two series will be called as what? Arithmetic progression. And which type of series won't we consider as a arithmetic progression? Okay, let's understand that. Let's say I'm taking here one example: 1 square, 2 square, 3 square, 4 square and 5 square and so on, right? So what is 1 square? 1 square is 1. What is 2 square? 2 square is 4. What is 3 square? 3 square is 9. What is 4 square? 4 square is 60. Now if you will observe this pattern, so what number will be the next in this series? So definitely if you will observe that it is 1 square, 2 square, 3 square, 4 square, so next should be what? 5 square. 5 square is what? 5 square is 25. Next it will be what? 6 square. 6 square will be what? 6 square will be 36. But here it won't be considered as arithmetic progression. Why? Because difference between two consecutive terms will not be same here. Let's check once. Okay, what is the difference between 1 and 4? It is 3. What is the difference between 4 and 9? It is 5. What is the difference between 9 and 16? That is 7. So in this case you will be finding that the difference between two consecutive terms are not fixed. So this one will not be considered as AP. Which sequence will not be considered as AP? 1, 4, 9, 16, 25, 36. And which one will be considered here AP? So this one, where we can see that it is in each of the sequence, it is the difference between two consecutive terms are same, right? Now we will be understanding that what is first term, second term, and so on. Let's say one example here also you can see that a few examples are given. Okay, you can follow that as well. So if I am writing here one AP, okay, let's say 10, 20, 30, 40, 50, 60, and so on. So in this case, and suppose it is ending here by 100. Okay, so in this case 10 will be considered as first term, which will be represented by T1. 20 will be considered as term 2. 30 is term 3, which means third term. 40 is fourth term. 50 is fifth term. 60 is sixth term. And here definitely few more terms will be coming, which is not written here, dot 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 dot. So which term this 100 will be considered as? Let's say we don't know that at which term it is, so we will be considering it as that it is nth term, and nth term is also known as what? Last term, right? Okay, and remember that first term is also denoted by a. Okay, now coming to the another point, which is common difference. What is called common difference? So here if you have observed, the difference between two consecutive numbers are what? 5. So definitely here if you I will say what is common difference. So common difference is always what? The next term minus its previous term. Previous term, it should be the next one which follows it. Okay, so common difference means what? Second term minus first term, right? Even we can write T1 as A1, T2 as A2, T3 as A3. These are just a symbolic representation. So common difference will be what? Second term minus first term. Next it will be third term minus second term, and so on. Now we have already discussed regarding that what is called first term, what is called last term, and common difference, right? And one more thing, which is n. So what is n? N is called the number of terms. Okay, so there are relationship between last term, first term, common difference, and number of terms. And what is that? That is an is equals to a plus n minus 1 into d. So what does it mean? That the last term is equal to first term plus number of term minus 1 into common difference. And how we will be using this one? So with the help of one question we can do that. Let's say one question is, find the 10th term of the AP, and AP is given, let's say 3, 7, 11, and 15. Okay, this is one AP given, and the question is find the 10th term or 11th term, and so on. You have to find out, suppose 11th term. Here if you will see that it is given 10th term, we will be finding 11th term, right? So we have to find 11th term. So which formula we will be using for this? The same nth term. Okay, so an is equals to a plus n minus 1 into d. So what is the first term here? Right, we have to observe. So first of all, in the place of n we have to write what? 11, that is a11, which means 11th term. A is what? A is the first term, which is 3. N is what? N already we have mentioned over here that n is what? N is 11. So here we will write 11 minus 1 and common difference. What was common difference that I have explained earlier? So common difference is what? Common difference means second term minus first term, or we can use third term minus second term. So let's say second term. What is second term here? The second term is 7. And what is first term? First term is 3. So 7 minus 3 is equals to what? 4. So here we will be writing what? 4. Let's solve it now. So here it is 3 plus 11 minus 1, which is 10, and multiplied by 4 because it is already present here. So 3 plus 10 into 4, that is 40. So here it is 40 plus 3, 43. So that's how we can find the other terms of the AP, let's say 100 term, 150 term, and so on. Even one example is given over here, as you can see, find the 10th term. Now, if we have already learned regarding the nth term, that is Tn, so there is another formula by which we can learn about what? Sum of n terms, right? And how? Let's see. So sum of n terms. First, before writing this, I'll give you one example. Let's say one number is 2, one AP, 4, 6, 8, 10. Now this is definitely, it is in AP, right? As the common difference is same. Now if I'll ask to you, what is the sum of these terms? What is the meaning of that? Sum of this term. So sum of this term means what? 2 plus 4 plus 6 plus 8 plus 10, right? So what will be the sum of this term? So sum of this term will be 2 plus 4, 6, 6 plus 6, 12, 12 plus 8, 20, and 20 plus 10, that is 30. So this is called what? Sum of these how many terms? Sum of these 5 terms, right? Now we will be learning the formula that without adding any number of terms, any number of terms which is given in AP, how can we find that? So the formula is sum of n terms is equals to n by 2 into 2a plus n minus 1 into d. Okay, when number of term, first term, and common difference is known, we can use this formula, or you can use another formula also, which is sum of n terms is equal to what? Number of term by 2 into first term plus last term. Okay, when number of term, first term, and last term is known, you can use this formula. Okay, let's do one question quickly. So let's say the AP is, I'm taking one AP, that is, let's say 3, 6, 9, 12. Okay, dot dot dot. Okay, dot 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 means it is infinite AP. Got it? Where the last term is not known. Now 3, 6, 9, and 12 it is. So in this case, if I'll ask to you that find the sum of 100 terms, which means if you will add 100 terms of this AP, what will be the answer? Let's solve it. So here the solution. So first we have to write the formula. Okay, formula is Sn is equals to n by 2 into 2a plus n minus 1 into d. Why we are using it? Because the last term is not known over here, so we cannot use this formula. Okay, so we will be using the first one. So Sn, in the place of n, what we will write? 100, as we have to find the 100 term. So similarly we will replace here n by 100 and here 2 into 2a. 2a means what? 2 multiplied by, here the first term is what? 3. So we'll write here 3 plus n minus 1. N minus 1, n is 100 again, minus 1 into d. D is what? D is the common difference. So D we can find by subtracting the second term with first term, which is 6 minus 3, which is 3. So here it will be 3. Now we'll solve this one. So 100 by 2, that is 50. 2 3s are 6. and here 99 into 3. Got it? Now 50 into 6 plus 99 into 3, 297. Okay, so here 99 multiplied by 3 is what? 297. Now what is the next step here? So next step will be that we will be adding this one, right? So let's add this. So here 250 multiplied by 6 plus 297. So 6 plus 297 is what? 303. Okay, and here we will again multiply 303 by 50. So we will be getting here 15,150. So that will be your answer. Even you can see the another example, which is sum of 10 terms here. Okay, now we came at the end of this chapter. So here we have already discussed regarding equal difference between the consecutive term, that is called the common difference, nth term of the AP, and the sum of nth term, right? Even we will be getting lots of question regarding the same. Okay, so now let's discuss that what will be the real life application of arithmetic progression. So it can be used in staircase design, it can be used in saving and investment. Not only it can be, it is used actually. Okay, in the sitting arrangement or monthly salary increment. Okay, sports competition or number pattern. In number pattern there is a vast uses of AP. Okay, number pattern and saving and investment, monthly salary increment, these all. Okay, so thank you everyone.